Hi there, this is Matt with OT3D.org. So this video is part of a series of videos that I'm making designed to teach occupational therapy practitioners, educators, and students about applications for 3D printing in their practice. My goal is to provide videos, resources, and instructional templates that will help walk you through the process of using a 3D printer. So in this video, we're going to be taking a quick look at some of the different programs that are available from Blender to Fusion 360, TinkerCad. We're going to talk about each one, what its strengths are, why you might use it, and I'll be linking some awesome resources in the description of this video to help get you started with the program of your choice. If you've been following my videos for some time now, you'll probably be familiar with the idea of STL and OBJ files. These are files that show three-dimensional objects and are the basis of 3D printing. Well, we've talked about some of the ways that you can find these files online, like Thingiverse, with a Google search. Makers Making Change has their library. What we have not yet addressed is how these kinds of files are made. So today we'll be walking through a few different methods of creating these files and when they are best used. So just to get started, let's talk about one that I personally started with. TinkerCad.com, if you are looking for a no-frills, beginner-friendly CAD software or computer-assisted drafting software, TinkerCad is an excellent choice, and I recommend it to most people who are just now starting out, especially if you don't have any background in it. So this program runs in your browser like Google Chrome or Firefox or Internet Explorer, so you don't need to download any additional software, and it's free to use. All you have to do is set up an account. So TinkerCad works on two basic premises: taking the pre-made 3D objects that are available and changing them to suit your needs. So you can do this by combining them, by making a hole and combining them, which creates kind of an empty space. I love this program. It is very intuitive once you get playing with it. You can glue and carve things together until you have a desired object. So this program is totally free to use and very beginner friendly. If you're starting out with a limited amount of experience, I would highly recommend it. One important thing to note is that while TinkerCad as a program is relatively simple, it is owned by Autodesk, which is a company that also happens to own Fusion 360, one of the programs we'll be talking about later. I've included a link in the description for a course by Autodesk that can help you with the transition from the introductory program of TinkerCad to the more complex Fusion 360 program. In addition to that, TinkerCad's website also hosts lessons for both educators and students to learn the basic ins and outs of modeling of the program, so you can either learn for yourself or help learn how to teach other people how to use the program. One thing that I want to include really quick is that in the future I will be making a video that will specifically be using TinkerCad. We're going to go from start to finish, start with absolutely nothing. We'll create a 3D model, export it, 3D print it, and test it, and then even make changes to it if needed. So I want you to keep an eye out for that video if you'd like to learn more about TinkerCad. So up next, what I'd like to talk about is a program called Fusion 360. So Fusion 360 is also owned by Autodesk, the same company that made TinkerCad. So Fusion 360 is more of a traditional drafting program. The program is generally used by starting with an outline or a drawing, then extruding or raising it up, and then modeling it using the editing tools that are available in the program. In my experience teaching individuals how to use this program, it's not quite as intuitive as a program like TinkerCad would be, but it does offer really powerful design tools that you might not have in TinkerCad. One example is Fillet or Fillet. That is a tool that rounds edges, which is very nice to have when you're modeling a shape that's going to be used by an individual, because you don't really want sharp edges on something. That's something that TinkerCad might not have, or at least would be a much more tedious process to actually go through and design. So there's a little bit more learning curve that's associated with this program, but there's really no need to worry. I'm going to be linking an excellent tutorial that I found on getting started with Fusion 360 that'll walk you through modeling an actual object. And after going through with that video, you should have some of the basics down. If you're still a little bit worried about learning the program, you can always look up additional tutorials. One of the cool things about Fusion 360 is a widely used program, so there's going to be a lot of information out there that's going to help you to learn the process. One thing to note is that Fusion 360 offers both paid and free accounts that have different features. For example, I'm a student with a .edu email account, so I'm able to use the student account that's offered, which offers a good balance of features while still being free. There are a couple different options that are available on their website. I'd recommend checking them all out just to see what's going to work best for you. So that just about covers Fusion 360 and TinkerCad. Both of those programs are excellent if you're going to be designing things that have specific shapes like cubes or spheres. The programs that we'll be talking about next, notably Blender and SculptGL, are actually programs that allow you to sculpt objects. So it's a little bit more fluid, more organic than using those hard shapes. So depending on what you're actually using the program for, this may be what you're looking for. So just to start out, Blender is a free software that's used often in the arts for 3D modeling. While it wasn't really made with 3D printing in mind, it can be used as an excellent tool for doing so with just a little bit of practice. Compared to Fusion 360, I found Blender to feel more organic, which is backed up by its tools used for sculpting. Another option that allows you to sculpt 3D objects is a web program called SculptGL, which I've recently been spending a little bit of time working with. As far as the relationship between the two, you can compare this to TinkerCad and Fusion 360. You might find SculptGL a little bit more intuitive and easy to use, but Blender being a more powerful tool that once you get over the learning curve is going to be great for long-term usage. So for Blender, I found an excellent video guide that will walk you through the steps of creating objects for 3D printing, and I'll link that in the description of this video below as well. Alright everyone, so that's going to cover a lot of the programs that I have experience with as far as learning how to 3D model. I think that all these programs that I mentioned are excellent to jump into, to learn, to practice. There are other programs out there as well, so if you wanted to do something that's maybe more programming minded, if you have that in your background, something like Rhino or OpenSCAD might be a really good option for you. If you're doing any photo scanning or using a laser scanner, there are also programs out there that will allow you to create 3D models based on those scans, which is a really cool emerging area of practice that I'm hoping that I get a little bit more experience with in the future coming up, maybe in even future videos. My personal path learning how to 3D model took me from TinkerCad to Fusion 360, and I found that each program has its strengths. I'll end up going to one or the other depending what I need at my local makerspace. Other individuals that work there have had better experiences with Blender and those sculpting programs, so a lot of it's going to come down to personal preference and what you're using it for. I hope that you'll check out some of the resources that I've linked in the description below. If you'd like to have a visual guide for this topic, I've created one that I'll host on ot3d.org that you can download there, with a bunch of other resources that I've made to help you get started in 3D printing for occupational therapy. Happy printing!